For B, what will this look like when we set it up? Okay, so we've got R minus 4.
Over 10 minus 3
Good.
equals 2, -2 or 7.
Okay, now if you set this up backwards, that's okay. Just hang tight. You should get the same answer, but if not, I'll look at it with you, okay? So R minus 4, Y's on top, right? R minus 4, and then 10 minus 3. All right, so now let's go ahead and clean up this 10 minus 3. What do you get down there?
4 over 7
Okay, so we have a 7 on the bottom.
equals 2 or 7.
All right, so now cross multiply. Okay, so now when you cross multiply with that 7 and that R minus 4, 7, R minus 4, make sure it's going to both parts. So 7R minus 28 equals, and what should I have on the other side? Well, it is 7 times -2. -14. Okay, is everybody good so far? Okay, so now we're solving the equation, so what are we going to do next here?
Add the 14.
Now add the 14. Add 28. Okay, so add 28. And we get 7R equals 14. And then our last step, yeah, and that's how we're getting R equals 2. Okay? All right, does anybody have a question or want me to do it the other way? We're all okay? You think you got it? Okay. All right, then let's scroll down. We're going to look at example 5. Example 5. So turn to that page or scroll for me. Okay? And this is the last thing we're going to look at in this section. Determine whether the function is linear. What's linear mean? A line. And explain it. So what we have to figure out is this set of data. If I were to stick it on a grid, would it make a line? Now, I'm not going to have us sit and graph all these out because we know hand sketching gives us a good estimate, but we may not know for sure if it's the exact line or not. Okay? So we want to come up with a different method than graphing. What else can we do to figure out if it's a line? Does anybody have any ideas? Okay, that's okay. All right, so when we're looking at this, what we're looking for is there a constant change? In other words, am I adding or subtracting the same amount the entire time? Okay, so linear, we're either adding or subtracting the same amount. Okay? All right, so up here, linear function, slope or rate of change must be the same for the entire problem. So slope or rate of change must be the same. Okay? And so what we're going to do is we're going to look at on example A here. I'm just going to focus on my x's, okay? And then I'm going to focus on my y's. And I want to make sure that I am adding or subtracting the same amount. So if I go from -3 to -2, what are we doing there? Adding 1, okay? So if I go from here to here, I'm adding 1. What about from -2 to -1? Adding 1 again, and -1 to 0. Okay, that's good. So we're good there. It has to be the same change. Okay? Now what about here from 11 to 15? Okay, 15 to 19, and then 19 to 23. Okay, so as long as we're looking pretty steady there, we're good to go. This is a line because it has a constant change. Okay? So your answer will be yes. There is a constant rate of change, or constant slope. Constant just means it's the same for the entire problem. Okay, so yes, there's a constant rate of change. Okay, so now, without doing any work, and just looking at this problem, what's my slope for this guy? Close, not 1/4. It would be 4. Why is it 4, not 1/4?
Because x is 1 and that's the bottom, so it's...
There you go. Okay, so we've got y's on top, right? So if I ask you to come up with the slope here, you should be able to do that. If you're thinking about slope, right, is rise over run or y's over x's, right? Y's over x's. Well, what was your y values? What were we changing there? 4 over 1, or or 4. So if I asked you to tell me what your slope was, your slope here would be 4. 4 over 1 or 4. Does that make sense? Okay, so y over x. Okay? Alright, so now let's look at letter B. Okay, let's start with our x's. So on our x's, -3 to -1, -1 to 2, 1 to 3. What's it look like going on there?
Plus 2.
We're adding 2. Do we add 2 every time? Okay, so that's good. Okay, so if I look from here to here, we're adding 2. Okay, so now what about 10 to 12? Okay, what about 12 to 16? Okay, so I can stop right there, can't I? Okay? I have to be adding or subtracting the same amount, and that's not the case here. I went from a 2 to a 4. Okay? So is this going to be a line? No. Okay? So you would put no. Not a constant rate of change. Now, could I ask you to find the slope here on this line? Yeah, Kevin's saying no because it's not a line, is it? Okay? So if you can't, if you're writing no, it means it's not a line, it's not linear, okay? And then I couldn't come up with a slope here because they aren't the same numbers, okay? All right, does anybody have a question on that? Okay, that concludes our notes for today.